Good morning, boys and girls. So we are in to week 2 of the coronavirus, and hope you guys are doing well. So this is Monday, March 23rd, and we are going to go over some more domain and range stuff. Anyway, so up here, we're going to focus on a couple different things dealing with domain. Before we worked on stating what the domain of functions was algebraically. Today we're going to try to make it all come together so you guys understand where this is going and how we're going to build on what we did last week. So you can also, first of all, dealing with functions, in order to identify if a function is a function, what that essentially means is one input can only have one output. So what does that look like on a graph? Well, I got 3 different graphs here on this graph right here, and you're going to always use the vertical line test. What that means is just get a straight object. This is clearly a linear function right here because that's a straight line going up and to the right, up and to the left. That is a linear function. So all linear functions are functions because they all pass the vertical line test. Now, what does the vertical line test mean? That when the vertical line only crosses the graph once. Okay? So that's what that means. When it crosses the graph once, then that means it passed the vertical line test. Therefore, that given function, that given graph is a function. So this graph right here, the linear one, passes the vertical line test anywhere around here. So does this quadratic. When this quadratic is put up here on the vertical line test, all quadratics going up or down like this will pass the vertical line test, because no matter where I put this vertical line, it's going to only cross that graph once. Now this right here is a circle, okay? And I can see that this does not pass the vertical line test because when I put the vertical line over it, it crosses it both here and here, or here and here. No matter where I put it, it's not going to work. And it just, if it crosses just once where it doesn't work out, then it doesn't work out. Think about it. How is it possible for me to put in, if let's say this is 8, okay? How is it possible to have an input of 8 and get 2 different answers? That's essentially what it means, okay? More importantly, domain is the input or the x value, and in order for a function to actually work, one input can only have one output. That's what it in essence means. So another thing you might be given is a set of points like this. 2, 4, 3, 6, negative 5, 20, 0, 0. Well, based on this information, all I know is this. I could plot these points if I wanted to, but I know this is a function because I have no evidence showing me otherwise. Now, on the flip side down here on this one, I got negative 3, 5, 4, 8, negative 3, 0. Wait a second. Negative 3 was 5, and negative 3 is also 0. So that means clearly this is not a function because of that. But I also did this. I have the y being 8, all right? This could actually work out. If this was a different situation and, I'm allowed to have the same output with different inputs, but I can never have different outputs with the same input, okay? And you'll see some examples like this going on. So that gets me through that lesson of some stuff you're going to see in today's work. And I will go through some other stuff with you. So, for instance, we know for facts, like if you want to we have a poster inside the room that states and shows all the graphs. So in case you forgot, remember, linear functions, let's do this. How about functions that have graphs that will always pass the vertical line test. Now we know linear, sorry, I can't spell. Linear, we know quadratic, we know absolute value. Just in your heads, remember the shape of all these graphs. I'll do the shape right here. So the shape, okay? Shape. Maybe put this in your notes for long term just so you don't forget the shapes of these graphs. We've worked with all these graphs so far this year by using point testers and all that stuff. We know these are always going to work. And we know this is y equals mx plus b. We know this is y equals, pretty much x squared, where the exponent is the exponent 2 is there, the variable is always down here. We know this is absolute value of x, that's how the function looks. What am I forgetting? Square root. So, okay. And then functions, so these functions will work, and whereas we know functions that won't work right now is the only one that we've been exposed to is y equals x squared plus y squared, or f of x equals, sorry, I'll start going into this notation now. And this is a circle. Okay, so that one does not work. Okay, what am I forgetting? Oh, when they're gonna give you just points and they're gonna say, are these points a function? You can feel free to plot the points and just see what kind of graph it makes. Again, and I urge you guys to do that when they're giving you a set of points and say, do these points make a function? Plot them, see what kind of graph you get. It might be a wavy thing, it might be all over the place, but as long as your function passes the vertical line test, that means no matter where I put my thing, if it crosses it only once, then it is a function, okay? And I'll answer your questions in today's Q&A at noon or 12:30. Went over the graph, so I show you guys that. Okay. Here's what I want to go over with you guys. And this is all in today's work, okay? And all today's work will have the answers underneath it. On the page after it, so you'll see what's going on. Domain and range. So if I'm given, all right, so check this out. I'm gonna give you guys 3 different examples, okay? This will say, my directions for this are state the domain and range. Okay, I'm gonna do them one by one so you guys see what you have to do here. I'll start easy and get hard. Y, and also, for the sake of what we're doing, the y is called f of x from now on, and your x is still called your x. Because remember, x is your input, or your domain. Y is your range, but we don't call it y anymore, we're going to call it f of x, okay? You'll see why this is coming up and why it's so important to start using the new notation. So if I got f of x equals 2x plus x, you guys by now know how to graph this, so it should be pretty simple, I'm hoping, for you guys at this point. Y-intercept is 6, slope is 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Doesn't make a difference, I'm just drawing a general shape. So rise 2, run 1, go back to my point down to left 1. There is my graph. Now, your domain is your x values. So this is a function, and this function will work. And I can input x values as far negative as I want, and I'll always get an answer. And I can also input x values as far positive as far as I want, and I'm always going to get an answer. So your domain for this, your domain is considered all real numbers, or as the book puts it, like that. Okay, that's the notation you can start using for all real instead of writing that out all the time. Your range for this, look at this. The range is, remember, it's your y values, right? So it's your answers, if you will. I will always get answers going up as far as possible, infinity, and I'm always going to get answers going as far down as possible, negative infinity. So I could state the range as Another way to write all real numbers is I could do this. I could do negative infinity to positive infinity, or you can just say all real numbers. Or again, the symbol you'll see in today's notes is that R double line kind of thing. Okay? So that's the beginning part of how you state domain and range when given a graph. Remember, X values for domain, Y values for range. Just look at your graph, see is it going up for infinity, down for infinity? Then it's all real numbers, or negative infinity to positive infinity. Again, you can write it any way you want because I'm going to understand that you get it. Let's do another one, increasing the difficulty just a little bit. I got y equals, we'll do a quadratic, x plus 3 squared plus 2, okay? Now you're going to see examples like this in today's work, so I'm giving you guys straight examples that will look just like some stuff in today's work. All right, now I'm hoping by now, after we've gone through this in the past with graphing this kind of stuff, there are easy ways to graph this. What makes the inside of this 0? And that's like your benchmark for where you're going to start point testing. Remember, you go above and below that by 2 for your window. All right, so what makes the inside of this 0? Negative 3. So negative 3 is my benchmark number that I'm going to use to help create the shape of this graph correctly. So I go 2 above negative 3, 2 below negative 3. So negative 5, negative 4, negative 3, negative 2, negative 1. And now just perform the math. Guys, this should be mental math for all of you. Negative 5 plus 3 is negative 2. Negative 2 squared is 4. 4 plus 2 is 6. Negative 4, 1. Negative 1. Negative 1 squared is 1. 1 plus 2 is 3. We know this makes this 0, so this is just 2. And again, the symmetry, negative 2 plus 3 is 1. 1 squared. We're going to get the same answers here, so 3 and 6. Now, let's look on our graph to see what happens here. Oops, I should have brought this over a little bit, but whatever. So negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So negative 5, 6, negative 4, 3, negative 2, negative 3, 2, and here's my symmetry. So now this is how this graph looks. So my domain, because we know this function works, because it's quadratic and all quadratics are functions, I can input any value for x negative. I can input any value positive for x, guys. I'm always going to get a different answer, no matter what. So again, your domain is all real, that's kind of messy. All real numbers, or again, you can just write negative infinity to positive infinity, because look at my function. I have no restrictions on my graph. I can always input any value in any direction. I'm always going to get an answer. Yeah, it looks like you stop around here, but realistically, I can keep on inputting values if I wanted to. Your range is now what's affected, and you can just tell by looking at this visually. So my range, the smallest number, and this is how you're going to write the range, the smallest possible answer I can get on it according to this graph is at 2. So your range goes from 2 all the way to infinity, because it goes forever upwards, no matter what. But it goes as low as this. This is also called the minimum, okay? So you're going to see some stuff in tomorrow's lesson about this, but I'm just giving you a heads up on this. This is called the minimum. Can't spell this early in the morning. Minimum, or as we also know, this is the vertex. Some language you should become familiar with as we continue to go through this quadratic stuff. So that takes care of that type of situation. Where is my paper towel? There we go. And again, my last one, just for the sake of today. Go find mommy, sweetheart. I can't do this right now. Let's do this last one. F of x equals negative 2x squared minus 4. Again, always ask yourself what makes this 0. Well, 0. So my benchmark All right, 1 second. Mia, hold on. Farrah, can you get Ava right now? Farrah, go to mommy, go to mommy. She'll be with you in 1 second. Okay. Sorry. Inside 0, 0. So go from -2 to +2, and just do the work. -2 squared is 4. 4 times -2 is -8. -8 minus 4 is -12. -1 squared is 1. 1 times -2 is -2. -2 minus 4 is -6. This makes this whole thing 0, so this is -4. 1 is going to be 1 squared, 2, -2, -6. As you see, pretty easy math. Okay? So now, let's look at this graph. Okay? So I'm doing this on purpose because I know most of my answers are in the negative. So -1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm down here like this. And I'm also over here like this. And I'm at -1, -6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this should be more curved, not looking like a V, upside down V, but it is a quadratic. So your domain, again, is going to be all real numbers, or you can put it as negative infinity to positive infinity. I do not care. All right, make your life easy. Just do the less, work smarter, not harder. Range. Now your range has we call this, for tomorrow's lesson, this is called a maximum, and this is also considered the vertex of this given quadratic. But your range now exists from -4. All your answers are going to be, the greatest answer will be -4, but the rest of the answers will exist in your negative infinity range. So that takes care of that. Last but not least, I want you guys to get used to some math notation so you guys start seeing this. Let's go through this right now. Last but not least is you guys will be asked to do some, it will say find for f of 6, and these are just random examples, or f of, let's just say -2. And they give you a function such as f of x equals 3 times x minus 2 squared. So find for f of 6 and f of -2. What this essentially is saying, just so you guys know for the notation, they're saying find y when x equals 6 and when x equals -2. So you're answering two different questions in one, but separately. So the input, when they want to know what is the output, what do you get as an answer when you input x? When you input 6 for x. Well, mental math, or just write it out. Okay. 6 minus 2 squared. 6 minus 2 is 4. 4 squared is 16. And 16 times 3 is 8, carry the 1, and we got 48. Okay? So f of 6 equals 48. That's how you write your answer, just like that. And then if I want to know what it is when it's -2, again, I just go back to the exact same function, and I input -2 for x. So 3 times -2 minus 2 squared. Well, -2 minus 2 is -4. -4 squared is 16, and 16 times 3 is 18. Now, I did not plan on this happening, but I'm glad it did. So when I input -2, I still get 48. Okay? So this is a function. This works because it's quadratic, and this proves what I said earlier about I can have the same output from two different inputs, but I can never have, ever, two different outputs for the exact same input. And we're going to be studying this week and going through this. So I hope this answers a lot of your questions. You might have a little confusion on some of the stuff, but again, I'm going to be available for you guys around 12:30 today, but I'll give you guys instructions on Google Classroom. And it'll have the instructions there for what to work on, and it also has the answers there, so you guys can ask me questions during today's Q&A session. Talk to you guys soon. Bye-bye.